Let's talk about the code 1014 with the sightseeing pair. It give us integer array values, and these values has size more than 2. And you want to pick up two index I and j, and you see this is the distance. You want to have the values minus distance to be maximal. So what we want is that we want to pick up two variables, right? And those variables should we want them to be as big as we can. And these two variables, we want an I and j, the distance as small as we can, right? Because that will be the sum of the value minus the distance. So let's find these two distance. So if we have these values have only two variables, right? And let's see, this will be the only pair. Only pair. Um, every time we iterate, let's say this is J, right? This is I. Let's say every time we iterate this J, and to be for example, let's say this I is our base candidate. Basic we use a variable called best, which represent in the previous um, index what is the base candidate of the left, right? So let's see for our J equals 1, right? The base will be at value 0, and the result is value 1 plus value 0 minus 1, right? And then we iterate this J to from 1 to a minus 1, right? So every time we iterate, so we have our base candidate. So it may be the previous base, but for our J, it will add one more distance, right? So the biggest in the previous, the base will be minus 1. And also we add one more candidate, that is um, if we from this J move one to the next, right? So this will be one more candidate of the left base. So every time we move, we also update that base. So we can write code for this, right? We can write, for example, base equals values 0, right? And we need a result equals to 0. So we iterate the int j equals 1, right? That is because j is the just by the description, right? J is the right candidate. J smaller than values of the length J plus plus. Yeah. So what we do is that our result should be max result values J. Let's have the I candidate, right? Base plus minus 1, right? And also, after we iterate, we can update our base. Base equals max dot max. Base the previous one, because we moved one index, the distance will um, increase by 1. So we'll set minus 1, right? And also, we need to have the values G. This will be moved to the left candidate. In the end, we return the results. In the Python code, I think code will be similar. Let's have base equals in the result equals values there, result set as there for G in range from 1 to length values 1. So we'll have result equals max result base as values G minus 1, right? And also we move one index for this, right? So we have one more candidate for the left base. Base equals next base minus 1 because the distance increased by 1 and the values J. In the end, we return result. It is a ON time complexity with constant space complexity.